Okay, so let's take a look at number 8. It says in triangle YAM, where M is a right angle, the sine of A is 12 over 15. Find the following. Okay, before we start doing any of this finding stuff here, let's take a look. Let's draw a triangle here. So we have triangle YAM, where M is the right angle. So let's put that in. M is the right angle, and we have Y, and A must be the other two angles. Okay, so then it says the sine of A is 12 over 15. If you guys remember, sine is the opposite over the hypotenuse. So that means 12 must be the opposite side, and 15 must be the hypotenuse. So we're going to use that information, and we're going to come over to our triangle. We're going to say, okay, well, here's angle A. The opposite of angle A is right here, so that has to be 12. And the hypotenuse of our triangle YAM is right here, so that's got to be 15. Okay, so we got a nice little setup here with our triangle. Now what we need to do is we need to find this missing side first before we can do anything else. So to find the missing side, when you know two of the sides, all you have to do is use that Pythagorean theorem. It says a squared plus b squared equals c squared. Key thing with this, c is always the hypotenuse. So let's set up our equation. A, we'll say, is 12, so we're going to say 12 squared plus b squared, so our b value, we don't know, we'll call that, now we'll just leave it b, is equal to c squared, which is the 15, so 15 squared. So from here, what we need to do is solve this equation for b. So first, we have to square these values. 12 squared is 144, plus b squared is equal to 15 squared, which is 225. Now from here, solving for b squared, we got to get b by itself, or solving for b, we get b by itself. So subtract 144 from both sides, and we should get 81 when you subtract 144 from 225. So we get b squared is equal to 81. Solve for b, take the square root of both sides. Now b is by itself, square root of 81 is 9. So this side must be 9. So our missing side, let's come over here and say it's 9. So now from here, the rest of this is pretty straightforward. Just use your SOHCAHTOA. Your sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All you gotta do. So starting at angle A, opposite of angle A, let's go ahead and get a new color in here so it's a little less distracting. So angle A here, 12 is opposite, 9 that we got from Pythagorean theorem is the adjacent, and 15 is the hypotenuse. So cosine, adjacent over hypotenuse, so we're going to say 9 over 15. If we want to, we can reduce that, but we'll reduce all these answers later. Tangent of A, same thing. Tangent we know is opposite over adjacent, so it's going to be 12 over 9. 12 over 9. Now we've transitioned, and now we're looking at the y. So now we're looking at this angle. Sine we know is opposite over hypotenuse. So we can either come in here and label opposite hypotenuse for the blue angle, and then 12 would be our adjacent. Or we can say, well, I know the sine of y is equal to the cosine of my other angle, so the cosine of A. So this must be the same thing, 9 over 15. Or you can just look at angle y and say, well, 9 is opposite, 15 is hypotenuse, so it's 9 over 15. Either way works. Cosine of y, well, that's equal to the sine of A, so that must be 12 over 15. And then the tangent of y is going to be the reciprocal of the tangent of A, so it's going to be 9 over 12. And that's it. If you want to check, you can do that by looking at your triangle over here. Okay, but that's all there is to that problem. Number 8 completed.